All right. Now, there we go. A little bit of a different look today, but that's okay. Ice Baby. I know. I don't know. It's not good news or bad news, but it is what it is. That's the reconfigured calendar. I posted this in Schoology, and I think I realized I didn't even have the first one posted in Schoology. So in the red folder for class materials, this is posted in there, and so now you can get a feel for what the rest of the unit looks like. Mostly we just pushed everything back. We rearranged some things, but that's several weeks away, so you weren't looking out that far anyway. This was already scheduled to be a 2-day lesson, so it worked out pretty well. It was kind of how it was going to go anyway. The first day you were just going to sit and listen to me do the lesson, and then the next day we were going to work a bunch of problems. So I'm going to assume, rightly or wrongly, I don't know, that you've watched this lesson. I hope so. If you haven't, especially if you're watching at home, go watch it now, and then come back to this one. And I've also posted, it's in the book, so you can couch chat, but I posted solutions, or a video of me working some of them. I've got that list right here. So today I'll work some more of them, and I just won't work the ones that I've already recorded. So I'll just work some more of them, and then hopefully between the videos that are already posted and what we do today, hopefully we'll be good on log and trig rules for integration. You can kind of see what's coming up. Integration. This Friday we'll take a day that's just pre-cal. In fact, that's exactly what we're doing in pre-cal right now. So I'm going to do this lesson in pre-cal tomorrow, actually, and then I'll do the exact same lesson for you guys on Friday. It's just inverse trig. It's been a while in pre-cal. And so this is strictly a pre-cal lesson, but it's one that maybe you've forgotten. And then we'll go into inverse trig derivatives and inverse trig integration. But it's integration, antiderivatives, tons of U-substitution in this unit. SAT school day next week is not really affecting you guys because it's for juniors only. And I think that seniors are just going to run their schedule like normal. So, it's on the calendar, but I don't think it affects you guys at all. So because it affects other stuff, it's nice that it landed on a review day. You guys are second period anyway, so it shouldn't affect you at all. And then we'll have a test on Friday. It's a Friday test, so I really need to get chopping on that. I have it, but it was a block day test, so I need to really cut it down to make sure the timing is okay. Of course, the danger is that means you get like one of each problem. Fewer problems means they're worth more. That's the deal with a shorter test. But we've got to make some allowances to make this stuff work this week. All right, so let's get a textbook and go over some from page 334. Again, I've already done some of them, but I'll do some more of them. So come grab one if you need one.
I woke up Monday, took one look at it, wrote something down.
Last unit, I started looking up the antiderivative. I saw it on Google. I was like, nope. I was like, that's why we haven't done that.
That's why we haven't done that one yet.
What did we write down for that?
Some natural law or something.
The negative natural log of cosine, of the absolute value of cosine of u is false.
Yes, because so let me review that one because that one does show up. Like antiderivative of secant, that one's kind of weird. You just have to memorize that one. But the antiderivative of tangent, which you guys were just talking about, if I rewrite that as sine over cosine, All right, that's still not even calculus. That's pre-calc. Oh, I should have picked a different letter because now I want to do a U substitution, and I don't have U's available. So we'll do this kind of substitution. We'll make it X. Then we can do a U substitution. Because I know the derivative of sine is cosine and the derivative of cosine is sine, I'm close. Now, which one do I want to pick? I don't want du to show up in the bottom because that doesn't work. So I usually pick u to be the bottom and hope that du shows up in the top. So if u is cosine, what's the derivative of cosine? Negative sine. So I need to throw a negative in there to make this work, and then a negative out front. So the antiderivative of du over u, what's that equal to? Natural log, good. Natural log of u, don't forget the negative. Natural log of absolute value of u plus c. So negative natural log of cosine plus c. And so, yes, it looks really weird if I just put it up there and say, hey, there's the antiderivative of tangent. And where'd that come from? You're like, well, it's not really that bad for tangent. And cotangent, it works the same way. Secant and cosecant, those are a little bit harder. Those are more just memorized. But this one you can usually figure out because of where it comes from. So that one's not too bad. All right, let's work some from page 334. 5 through 27, 35 to 45, 49 to 55, and odd applied to all of that. And on another video, our solutions to 13, 15, 23, 27, 45, and 51. So let's work some today that are not those, because those are already worked and available to you.
Number 19.
Number 19. The integral, or the antiderivative, of x to the fourth plus x minus 4 all over x squared plus 2. Oh, there's a rule that goes with this one that leads to a not fun situation. Do you know what the rule is, what I'm referring to? And in fact, it has to be long division because I can't synthetic divide because of that x squared. So I have to long divide. If the top is bigger than the bottom, top degree is greater than or equal to the bottom degree, then you have to long divide or synthetic divide. But for this one, synthetic divide is only possible if it's x plus 2, x minus 3, not an x squared. So I'm going to have to long divide, do all the algebra for long division, and then worry about antiderivatives. A few of you on the test, you made this mistake where you did the initial algebra correctly, and then you didn't actually take the antiderivative. And that's an error that happens here. Like, people remember, oh, I got a long divide. They accomplish the long division, like, I'm done. Like, no, now you're ready to work the problem. So let's long divide. Yeah, it's been a while since we've long divided. I don't know that we've ever long divided in here. But it works just like, 5th grade long division or whenever you first learned long division. So something times x squared gets me to x to the fourth. Well, x squared times x squared would get me to x to the fourth. And different people put it in different places, but I like to line up all the powers in the same column. To me, that's just the neater way to do this. So multiply it back, we get x to the fourth plus 2x squared. But then we subtract that. So x to the fourth goes away, right? We arranged for that to happen. That's why we picked x squared, so that's not an accident that that lead term goes away. And then we've got negative 2x squared plus x minus 4. So I need something times x squared to get me to negative 2x squared. All right, we don't worry about the rest of the stuff. We just worry about the lead terms, and the rest we'll just deal with it later. So negative 2 times x squared would get me to negative 2x squared. Negative 2 times negative 2 would be negative 4. And we change the signs. The x squareds go away. The lead term always goes away, right? If you pick the number right correctly, then that's going to happen. X comes down. Minus 4 plus 4 goes away. And so I've reached the end of the line here. And so x is either my remainder, but that was the 5th grade way to do it, to say remainder 7 or remainder x. We're going to do it as x over x squared plus 2. So tons of algebra, but I'm left with x squared minus 2 plus x over x squared plus 2. Oops. And that is not my answer. That's the algebra part, but I haven't taken an antiderivative yet. I've not integrated. Again, that was a fairly common mistake on that most recent test. You do a lot of work, a lot of good work, a lot of work in the right direction, but you're not done yet because you haven't taken an antiderivative. Okay, the first couple are easy. That would be x cubed over 3 minus 2x. And then for this one, let's slow down a little bit here. That looks like a U-substitution. What do we think U should be? The bottom. And then we hope that du is the top or something close to the top. 2x dx. That's pretty close to the top. That's almost perfect. Easily fixable with a 2 and a 1/2. X cubed over 3 minus 2x plus 1/2 du over u, which is natural log. So this is what shows up a lot in this lesson, or in this unit. So x cubed over 3 minus 2x plus 1/2 natural log of the absolute value of u, which is x squared plus 2. Kind of short-circuited one step there because I was almost out of room. I substituted the x squared plus 2 back in for u, kind of on the fly. This is another one where the absolute values aren't necessary because x squared plus 2 is always going to be positive. So if you look in Calc Chat or a multiple choice test, that's going to be parentheses there. But if you're doing a free response answer, this is not wrong. This is completely okay. But that's that subtle difference between parentheses. Books and answer keys will switch to it if it's not necessary. But if you're free responsing, you don't have to do that. You can leave it like that. Any question on 19? Yeah, that was a good one because long division. Haven't done that in a long time. Nick?
Did you just move like the x cubed, the numbers just out to the side? You can just do that, right?
So, I guess officially what I did was I integrated all of these separately. Like that. And you can do that with adding and subtracting. You can't do that with multiplication or division. But with adding and subtracting, you can handle the pieces separately.
Okay.
Just like taking a derivative, you can take the derivative of plus and minus separately. It's no big deal. It's multiplication and division where we get the quotient rule and the product rule.
Okay.
Good question. All right, what else?
23.
1 over square root of x, 1 minus 3 square root of x, dx. Any guesses for you? Macy? Or just plain lost on that one?
Is it 1 minus 3 square root of x?
It is. Do you know why, other than we usually make it the bottom and we'll just hope it works?
Is it?
Just parentheses, and you don't want x to be u. Square root of x to be u.
Okay, you definitely don't want this to be u, because then this would be a mess.
Right.
So from that reason, that's kind of a complicated piece, so let's pick it and hope the rest works out. Which is reason enough, and we'll see if that works. I'm going to change that to x to the 1/2. Because you don't, some people do that in their head, but you don't take a derivative of a square root, you take a derivative of a power. So whether you show that or not, you don't have to, but let's see, derivative of 1, that goes away. So minus 3/2 x to the negative 1/2. And then if I'm paying attention, I think that's really good news. Why do I say that? What's 1 over the square root of x? That's x to the negative 1/2. So we're pretty close here. That is x to the negative 1/2. Or you could write it the other way and say this is negative 3/2, 1 over the square root of x. So that is part of du. I got to fix the negative 3/2, but that's the easy part. So negative 3/2 and negative 2/3. And so all of this then is du. And I mentioned this before. For us, for now, most of these are sort of rigged problems where you pick the right u. It's like, oh, it magically works out for me. Later, there's more complicated stuff that we get to some of it, but we don't even get to most of it, where it doesn't work out so nice. But this, you're on the right track when this happens. Du over u is natural log of absolute value of u. So natural log of absolute value of 1 minus 3 square root of x plus c. And I think I do need the absolute value on there because 1 minus 3, that could be a negative number. But if you're not sure, just leave it and don't worry about it. What else? By the way, omit 43. I don't know if I said that or not. 43 doesn't work. 43 is beyond what we can do. So we're going to omit that one. You done enough of these to know how to fix that to make it work for us? If u was x squared minus 9, then du would be 2x. That would be a lot better. So I think this was a typo putting that x on there. Otherwise, it's more complicated. We don't want to mess with it. Especially this one. So omit 43. else do we want to look at? There are some with limits. Do we want to do 49, 51, 53, 55? Those have limits on them. I mean, it's just that extra step at the end.
Could we do 55?
Sure. 55. So this looks like a U-substitution problem. Guesses for what U should be? Kind of getting in the habit here. Maybe you're recognizing which we usually pick for U. I mean, everything in this unit almost everything in this section is du over u, or is turning into that.
Couldn't you do 1 minus cosine?
If I do 1 minus cosine, the derivative would be just sine. So I'd have that theta would be messed up, and then du would be in the bottom. So if I make it be the top, that doesn't work so well. Let's let u be the denominator. For one, that puts us on track for a natural log integration. And for number 2, if I take the derivative of theta, this looks a little bit weird, but I'm taking the derivative of this stuff with respect to theta, not with respect to x. So the derivative of theta is 1. Derivative of sine is cosine. And so they rig this one up nice. There's no even adjustments to do. There's du and there's u. Careful with those limits, though. I'm not even going to write them because, well, those are theta limits, and I need u limits. You guys did much better than people usually do on this part of the last test, the limit stuff. So good for you guys. If you want to use 1 and 2, that's fine, but that means you got to work the problem and put it back in terms of theta. Most of you, rightly, said, you know what, let's change these limits. Let's see, so if I plug in 2, I get 2 minus sine of 2. If I plug in 1, I get 1 minus sine of 1. And those are my new limits because those are u things now. It's going to be a weird looking answer. But antiderivative of du over u would be natural log of u. And I'm not putting in theta minus sine theta again. Here's the common mistake is you switch the u's, or you switch the limits to u stuff, but then you switch the u back to theta, and now you've got theta but u limits. I don't want to go back to theta. I want to keep everything with u. So I've got a u antiderivative, and I got u limits, so I'm good. I don't ever have to go back to the theta stuff. So natural log of 2 minus sine 2 minus natural log of 1 minus sine of 1. That's an okay free response answer. So most of you are going to stop there. If you check in Calc Chat, or if you go multiple choice, they're probably going to use some properties of natural logs that you might have forgotten. Well, first let's talk about absolute value. Sine is always between 1 and negative 1. So 2 minus this is always going to be positive. So I could drop the absolute values on that. The biggest sine is ever going to be is 1. So I could drop the absolute values on this as well. But I'm going to leave them because that's a little bit complicated. The natural log rule is divided by. Subtraction can turn into division. So 2 minus sine 2 over 1 minus sine 1. And I guess we should just throw in absolute value bars on all that just to be safe. But I don't think it's needed. How about plus c? Do I need a plus c on that one? No. So that was a good one because that's a good one to show that last natural log property that we don't use very often. Looking around, are there any others that you want to see? Yes.
25.
25. Wondering if I'll have space to do 25. We'll see. Antiderivative or integral of 2x over x minus 1 squared dx. Let's see. U-substitution for sure. I'm wondering if I want to do algebra first. If I FOIL that out, there's two things going on in my mind, and I really don't know which one is going to work. I can let u be x minus 1, and then du would be dx, and so I'd have to do that double reverse substitution thing on the top. It's not my favorite thing to do. Or I could do algebra first, and in the bottom square that out, and I would get x squared minus 2x plus 1. And then if I let u be the denominator, du would not be the top, because I'd have 2x minus 2. So I don't think I want to do this way. I was hoping it would work out where, right, if there'd been a minus 2 up here, that'd been really nice, because then it would work. But there's not, so I don't think that's the way to go. So let's back up and try u equals x minus 1. And that means that x equals u plus 1. So I got to do that reverse back substitution business. So antiderivative, I'm just going to move the 2 out front. I'm going to replace x with u plus 1. And in the bottom I've got u squared. And du is the same as dx, so that worked out okay. Alright, so this is that tricky one where we had to do that extra step in there. I'm going to divide these up into, let's see, u over u squared would be 1 over u. That's going to be natural log. The other one I'm going to write as u to the negative 2 because that's a power rule. So I'm going to integrate 1 over u and I get natural log, absolute value of u. I integrate u to the negative 2. I increase the power by 1. Divide by the new power. I need a plus c on there, but I'm going to substitute the x minus 1 back in first. So 2 times natural log of x minus 1 plus, or actually just minus now, 1 over x minus 1 plus c. That was definitely a tricky one. Good one to ask. right, we did a bunch, and there's more posted online. So let's stop there. And tomorrow is actually, I think, a little bit easier than this was. This is one of the harder ones of what we've got coming up. Well, till we get to inverse trig. That's kind of a pain. But we'll get there. The derivatives and integrals of inverse trig is next week. So the rest of this week is not too bad. And then next Monday and Tuesday is kind of a pain. And then we'll test next Friday. So not too bad today. Get reacclimated to school. Hopefully by now, if you did some of it on your own and did the ones we did, hopefully you're caught up and maybe not have too much calculus homework tonight. And tomorrow we won't go over any of those because we just did a big chunk of them between the ones that are already posted and the ones we just did. Hopefully I'll have wireless connectivity tomorrow. We'll see.